And our last talk will be presented by Arno Carrel from the IRSN, and the title is Simulation of Radon Products Atmospheric Dispersion at European Scale, Assessment of Different Air Contamination Indicators. Arnold, the floor is yours.
Good morning, everybody. I'm trying to share my screen, so tell me if you see the presentation. Can you see it? Or?
Yes, we see it.
Perfect. So, good morning. I'm Arno Carrel from the IRSN, and I will talk to you this morning about the...
No, Arno, excuse me. We are seeing not the presentation mode, but the PowerPoint file.
Okay. I haven't shared the right screen. Is it the issue? Okay, maybe I'll try another shot. Écran complet. Okay. Tell me if it's now in full screen.
Okay, now it's full screen.
Okay. So this presentation, it is about the outdoor radon. And our goal is to model the outdoor radon air concentration across Europe. And you can see on this figure a map of the modeled radon air concentration today at noon all across Europe. And you can say, for example, today in Slovenia, the radon air concentration are supposed to be between 1 and 3 becquerel per cubic meter. So this is the kind of product I will show to you today, and how we obtain this map and how it was validated. So this is the purpose of this presentation. So the context is the fact is the radon have a half-life of 3.5 days. So it leads to this gas to be transported across long distances, and radon gas can typically be transported across the whole continent. And to model this behavior of outdoor radon, we are using LDX, which is an one of the IRSN atmospheric transport model, which is dedicated primarily to the crisis management and dedicated to the long distance contaminations. And it was previously, for example, it was previously validated against the Fukushima accident or against the radon progeny wet deposition. So the objective here is to validate and to model and to validate the radon 222 air concentration against the Aegis observation, the radon observation made in Austria, and to validate the model. So this is now the simulation frameworks. So in the center, we have at the middle of the topic here, we have the atmospheric transport model. So LDX, it's an Eulerian long-range transport model, and it is mainly used for the nuclear emergency responses. But it can be used for other purposes, for example, for the radon transport. This model needs inputs, and as major inputs, here we need a radon exertion flux map at the European scale. And we also need the physical properties of the radionuclides we are trying to model. And of course, he also needs some meteorological data inputs. And in this case, the meteorological data are provided by Météo France. And to be more precise, it is the ARPEG numerical weather prediction model, which is used for this study. The output of the atmospheric transport model, it's the concentration of radon in becquerel per cubic meter with a resolution of 0.1 degrees, so it's corresponding to almost a resolution of 10 kilometers at our latitudes. And this concentration can be displayed as time series or can be displayed as air concentration maps. And this output can be finally compared to the edges observation and to determine if the validation is performing good enough or not. So about the radon flux map we have used in this study, radon flux maps is determined by, of course, the soil uranium content, the physical soil property, and the soil moisture and temperature of the soil. And but here we have to wonder that the soil humidity it's have a very huge impact huge impact on the radon flux maps. And so we have used the radon flux maps calculated by Karsten and Levine, and they proposed two different radon flux maps with two different soil humidity input data. One is based on the ERA 5 land soil model provided by ECMWF, and the other soil moisture map is provided by GLDAS NOAA from the NASA. And so both maps were used to this study. But yeah, the radon flux map, it's important data. And as for the observation, we have used the AGES network radon observation. So this is the 10 station used to perform the comparisons. And you can see here the map of the location of the stations we use for this study. These stations have very different neighborhood elevations, and you can see here also the mean value for the year 2021 in terms of radon outdoor radon concentration measured on these stations. So it goes from a lowest value of 2.5 becquerel per cubic meter in mean for the whole year, up to 7 becquerel per cubic meter of radon in Villa. So we compare the time series of the station to the modeled one, and it have to be noted that this work have already been done against the ICOS radon air concentration network. So and we have already at the time we have already obtained quite good result in comparing to this radon air concentration network observation, and it was confirmed here with the AGES observation network, and with mean correlation of 62% and a factor of close to 70%. And but of course there is some station where the results are very good. For example, for this base station, where the mean bias is very low and the trend are quite well kept by the model. But for some station, the model perform badly, but we have some explanation for this bad performance. One comes from, for this particular station, we have some explanation about the the technology of this particular station, and it seems that our model cannot well represent this the radon air concentration measured, and especially mainly due to the equilibrium equivalent concentration hypothesis of the measurement. And it also has to be noted that for many situations we have trouble to determine the right concentration, and it's mainly due to the vertical turbulent mixes processes, which is very difficult to model at this scale. And it is known, and we have to work on this topic, that the model have this resolution, have difficulties to represent, for example, the night time where the atmosphere is very stable, very still, and the model are today not very good to represent these particular situations. And especially if the area is mountainous, for example. And so this is one of the output products we have performed, and this is a map of the annual mean outdoor air concentration for each Euro region as defined by Eurostat. And so you can see here we have very strong discrepancies between each region, with some region can achieve a value close to 5 becquerel per cubic meter in mean for the whole year 2021. And at the opposite, some regions have very low air concentration during the year. But finally, even for the highest region, the air concentration are very below the 300 becquerel per cubic meter average value. So it's as it was said before, and the outdoor air concentration, it's absolutely not a concern for the health. And this is the same result, but displayed for each countries. And we can also have on this table the air concentration maximum for a week and the minimum. For example, in Portugal, we in 2021 there was a week where the mean outdoor air concentration was close to 8 becquerel per cubic meter. It was the highest week in the whole Europe for the year 2021. At the opposite, Denmark, Malta, or Netherlands never achieve, never reach outdoor radon air concentration greater than 2 becquerel per cubic meter. So in the whole year, we never reach a significant value of radon air concentration. And before finish, I would like to present some perspective. And one of the utility of this modeling, it's we are able to perform forecast of radon air concentration, because we only need to make some hypothesis on the radon air concentration maps, on radon exhalation maps, and using the forecast of the numerical weather prediction models, we are able to forecast the radon air concentration for the coming 4 days. And it's have an interest for the radon air monitoring. And it's also have an interest when we add the filiation and the deposition processes of the radon progeny, because the radon progeny, when they are scavenged by rainfall events, they lead to a very meaningful, to very important, sometimes increase of gamma dose rate, which leads to a false alarm in the monitoring network of the gamma dose rate, which were surveying the radiation environments. And it was already, and this work were already published. And so on the right, it's a map of the movie of the prediction for the coming days. And you can observe the two phenomenon. During the night, the radon is concentrating on at the ground level, because during the night there is a much less efficient vertical mixing on the atmosphere. And you can also observe that the meteorological trends can move from west to east, the radon air concentrations. And yeah. So this is both phenomenon you can observe from of this movie concerning the 4 coming days. And to conclude, I would like to focus on the fact that the radon exertion flux maps have a very strong influence on our modeling. And so we have tend to prefer the SAMWF soil moisture to compute the map, but to compute the radon exhalation flux map. But as you can see here, in changing the soil moisture data, it leads to quite very different maps of outdoor radon. And okay, and we also one possible future work is to work on the changes about the radon air concentration, especially due to the climate change, because the precipitation systems will change and the wind situation will also change in Europe in the coming decades. So it can lead to important effect on the radon air concentrations, which will be measured in the coming decades in Europe. So thank you for your attention, and if you have any question, I will be glad to answer.
Okay, thank you very much. We are a little bit late with the schedule, so are there any urgent question from the audience? I see one.
Thank you, Arnaud, for your presentation. I've just a quick question. Maybe you say it, but I don't understand it. You said that the results are correlated to the radon exhalation flux. So my question is about how this radon exhalation flux is calculated. Is it either an average on the year or the week, or I don't know, or is it a dynamic data which can change each day due to, for example, a change in soil moisture due to precipitation?
Yeah, and we have tested both monthly mean data and daily mean data of radon exhalation flux maps. The daily one do not lead to any significant improvement on the modeling. It only lead to have heaviest input data. It do not lead to any improvement. So in this study, we have used the monthly radon exhalation flux maps. So we have a maps for each month, and it's satisfactory enough for this purpose.
Thank you. I see we have a question online from Arturo.
Yeah, good morning. So I would like to follow this question, yes, because I mean, if you use the monthly one, it's okay if you make average mapping, yes, for radon. But if you go in this radon, when you say day, night, and things like that, I mean, the changes in the exhalation rate, you have to take into account at least the daily or hourly the changes there, because otherwise you will not consider these changes in humidity that can happen due to rain or whatever things it happening there. Yes. And another following this, I mean, also the resolution of your temporal, but also the spatial resolution. I mean, when we do this kind of modeling things, we find that, okay, depending on the station, if you put a station in a coast, for instance, a radon, then I mean the resolution of the exhalation map, the exhalation measurement, and if you move it 1 kilometer from the other station, the radon concentration can completely be different. Yes, so if you compare model and stations, I mean, should we take care if you use these 10 kilometers, as far as I remember, of the spatial resolution? So I mean, this study is good if you make global things, but if you go more in the daily, I mean, I would maybe recommend to go to lower resolutions maps and also in the time resolution. We did it a lot in this ICOS, in the trace radon project. I don't know if you have heard about that, but we did a lot of this work there. We did this map of karst center, and so we see a lot of these points that maybe in the future we can discuss and comment with the people of trace radon. Yes. Okay. Thank you very much.
I will try to make a quick answer, but we can talk about these topics later. But yeah, we were involved in trace radon as observer. We were not involved as the actor in trace radon, so we have only access to the. But it was already great to final data of the trace radon project. So that's the point. And yes, the spatial resolution is constrained by the computation time mainly. But you are right. For example, for the MES aid station in Ireland, which is very near to the coast, we got some issues in comparing the radon air concentration to the models. And yes, some stations are unable to be compared to the modeling, especially because they represent some very local behavior which are not catched by this crude model, as you say. And of course, it could be a very important way to improve the modeling. About the night event, it seems that radon air concentration on night, it's mainly driven by atmospheric behavior of the atmosphere more than to the radon flux. But if you have any data of showing the radon hourly exhalation flux, sure we can try to make an improvement on the reduction flux maps and try to see if we can have a very meaningful and very important impact on the model. Yeah, could be interesting to test an hourly exertion flux map.
Okay, thank you. You have just a last quick question from Yelena.
Okay.
Thank you very much for the presentation. I'm coming from a regulatory side, so I'm looking for the implementation of radon flux maps for Europe. And I'm just wondering if has been considered that radon concentration can be used as a predictor for earthquakes, because I know that for decades that was an issue, and the underground water has been now somehow checked if we can predict through radon concentration in underground water, if we can predict earthquakes. There is a huge program, Artemis, going on, but this is related to water. So I'm wondering if the concentration in air can be also used. Maybe this is an old question, but I'm just wondering, because you are making such nice modeling, then maybe this can be useful. Thank you.
Yes. I think it's a tough question, and our modeling can be used to determine, possibly our modeling can be used to determine the regular air concentration of radon, because of course, if there is a coming earthquake leads to a very strong increase of radon air concentration, of outdoor air radon air concentration, it will mismatch with the modeling. But this station or these stations have to be well modeled for the regular situations. And of course, if, for example, if the station is as modeled as this one, it could, a radon peak measure due to a coming earthquake will be very well detected. But if it's for this station, it will be much more challenging to determine if the change between observation and simulation is due to an earthquake or only due to the fact that the modeling is not performing well. So possibly it could be a very interesting subject, but I
Okay.
think we are far to answer.
Thank you. I'm sorry to have to break the discussion. So now we are a little bit late. I look at Warren. Do we change our schedule?
Yeah, so we will break for coffee right now and rejoin at 11:15.